Welcome back to Silicon to Software. I'm your host, Imran. 20 years in PCB manufacturing. And today, we're talking about the hardware that keeps delivery drones from falling out of the sky. Let's start with a crash. October 1st, 2025. Two Amazon Prime Air drones hit a construction crane in Tucson, Arizona. Both took substantial damage. The FAA opened an investigation. So did the NTSB. Amazon paused deliveries, and here's the thing, this wasn't a one-off. Amazon's drone program has logged crashes going back years. Rain has knocked out LiDAR sensors. A drone went down on an apartment building in Texas, propellers still spinning on impact. None of this means the technology is broken. What it means is the hardware is getting tested by the real world. Hard. So let's actually talk about what's keeping these things safe. First layer, the flight controller. This is the onboard computer making decisions every few milliseconds. And modern delivery drones don't run just one. They run two, sometimes three, cross-checking each other in real time. If one starts drifting, the others catch it before it becomes a problem. The sensor here is called an IMU, Inertial Measurement Unit, tracks speed, orientation. Drones carry 3 of them, and there's an algorithm called a Kalman filter that blends those 3 readings together, throws out the bad data. This is running hundreds of times a second. Miss that timing, and the whole system stalls. Second layer, sensors, LiDAR, radar, cameras. Here's the problem nobody likes to admit. Not one of them works well in every condition. LiDAR's precise, but rain scatters the laser. Radar cuts through weather fine, but it's less detailed. Cameras understand what they're looking at, but they fail in low light. So you fuse all 3. Radar tells you something's there. LiDAR tells you its shape. Vision tells you what it is. Together, that's how a drone tells a crane from a bird from a building, and reroutes before it hits one. Third layer, batteries. Now this one gets skipped in most drone coverage, and honestly, it shouldn't be. These drones run on lithium polymer packs, same chemistry as lithium ion, different structure, and that structure matters in a crash. A puncture can trigger thermal runaway. That's a battery catching fire mid-flight. The fix is a battery management system, watches voltage, temperature, charge at the individual cell level. But here's the catch. The battery system doesn't land the drone, it just flags the problem. The flight controller makes the call. 2 systems, both have to work. Both have to talk to each other correctly. Beyond the aircraft itself, there's a coordination layer called UTM, Unmanned Traffic Management. Think of it like air traffic control for drones, keeping hundreds of aircraft from different operators aware of each other in the same airspace. And there's a security layer most people never even think about. Command link encryption, GPS authentication, because a drone with perfect sensors is still vulnerable if someone can spoof its position or jam its signal. So where does this all land? Amazon wants 500 million drone deliveries a year by the end of the decade. Zipline just crossed 2 million deliveries and is expanding into major U.S. cities. The volume's coming. Whether the hardware is fully ready, that's still an open question. And that's exactly the problem engineers are racing to solve right now. That's the rundown. For the full technical breakdown, sources, standards, the engineering data behind every claim, head to silicontosoftware.com. Thanks for listening.